as I discussed before all the formulas and basics to you, you have to remember all these basics to study about complex numbers. So I just tell you the basics now. Now we will study about what is complex numbers, its equality, its multiplication, addition, and every property. So let's get started. So now we will study about complex numbers. So we know that first we will know from where this number is come from. So the equation we know, which is x square equal -1. Okay, it has no solution in the set of real numbers. This equation has no solution in the set of real numbers, because this square of every real number is either positive or 0, and here it is -1. So therefore we feel the necessity to extend the system of real numbers. We all know that this defect is remedied by introducing complex numbers. So from where complex number comes, okay. So what is the basic definition of complex numbers? That a number of the form x plus iy, where I is the iota, yani x means x plus iota y, where iota is under root -1, and x y are both real numbers, is called complex numbers, denoted by symbol z and written as z is equals to x plus iy. So a complex number is also defined as an ordered pair. Which is x comma y of real numbers. Okay, if we write z equal x plus iy or x comma y, then x is called the real part and y is the imaginary part. So this is real part and this is imaginary part. Okay, so we write real part, we denote it by rz, and imaginary part as iz. Here rz is x and iz is y. Okay, so now we will take an example. So here we have an example, which is z is equals to under root 3 plus 5 iota. So now we'll find the rz and iz, that is the real part and imaginary part of z. So what is the rz here, which is under root 3, and what is iz, which is 5. Okay, so a complex number is said to be, now we will study like what is, we call it a purely real and imaginary part. Okay, so a complex number is said to be purely real if its imaginary part, that is that this part is 0. Okay, and purely imaginary if its real part, that is this part is 0. Okay, if this part is 0, then it is purely imaginary, and if this part is 0, then it is called purely real. Okay, now we will write it. So we write it that a complex number is said to be purely real if its imaginary part is 0, and purely imaginary if real part is 0. Now you understand, if x is 0, then iota y, that is purely imaginary part, is not 0, does not equals to 0, and if purely real, then its imaginary part is 0. Okay, so if we have now we will take as z is equals to a plus 0i. So if we have this, then we will simply retain it as a. Okay, because its imaginary part is 0, that is it is purely real. Okay, this is the example we can write, and we will denote c is complex number, the set of all complex numbers, by c. Okay, so we'll write denote the set of all complex numbers by C. So now this time is to study about the properties of complex numbers. So first is equality of two complex numbers. Okay, if we have, let z1 equal x1 plus i1, or we can write it x1 comma y1 in ordered pair form, or z2 equal x2 plus iota y2 or x2 y2, then it is said to be equal, means z1 equals z2. If we can write it like z1 equal z2, means two complex numbers can be equal if x1 equal x2 and y1 equal y2. So it shows that two complex numbers are equal if and only if the real part of one, that is x1 and x2, real part of one is equals to the real part of other, and imaginary part of one is equals to the imaginary part of other. Now the addition of complex numbers. So we have z1 and z2. So if we add both of these complex numbers, what we will get? Real part add with real part and imaginary part add with imaginary part. Okay, so now we will take an example. Let we have z1 is equals to 3 plus 5 iota, and z2 is equals to 7 minus 8 iota. Then what we will get it sum? z1 plus z2 is equals to 3 plus 7 plus iota 5 minus 8. So what we will get, which is 10 minus 3 iota. So this is the sum. Okay. So now we will study about the properties of addition of complex numbers. So first one is commutativity, that if we add two complex numbers z1 plus z2, then it will be equals to z2 plus z1. Next one is associativity. So what is z1 plus z2 plus z3? We will change the bracket and this should be equals to this. Now next is identity. Which is 0 comma 0. We can write it like 0 comma 0 or 0 plus iota 0. This is the additive identity. Okay, so how can we write it? We can write it as so we can write it like this, that if we have two numbers, real number xy plus 0 0 equal xy equal 0, okay, so we can write it like this. Similarly, we can do the inverse properties and cancellation law properties of complex numbers in addition. Okay, it is same. So now I will tell you the multiplication of two complex numbers. Like if we have two complex numbers, that is z1 and z2, whose values are, if z1 is equals to x1 plus iota y1, and z2 is equals to x2 plus iota y2, then how we will multiply, how we'll do product of this z1 and z2. So it is written as z1 into z2, and now what is the value of it, which is x1 plus iota y1, x2 plus iota y2, which is equals to x1 x2 minus y1 y2 plus iota x1 y2 plus y1 x2. So if we do product of two complex numbers, what we will get, which is this. Okay, or if you want, we can take an example of it. Like if we have two complex numbers, example should be like this. If we have 3 plus 5 iota into 7 plus 6 iota, then what we will get? 3 by 7 minus 5 by 6. We will take it like x1 x2 y1 y2. So what is x1? 3. What is x2? 7. Okay, we multiply them, then minus, and what is y1? It's 5, and what is y2? It's 6. Okay, so now plus iota 3 into 6 plus 5 into 7. Okay, so what we will get? 21 minus 30, we get minus 9 plus 53 iota. So this is our answer. We can multiply two complex numbers like this. So now the difference of two complex numbers. So we have two complex numbers z1 and z2. If we difference them, we will get z1 plus minus z2. So we can do it with example 2. You can solve it. Now we will study about division. Okay. In complex numbers. So what is the division? So we have a complex number like a comma b. Okay, we have complex number a comma b is said to be divisible by a complex number like we are dividing it by with c comma d. So if there exists a complex number x comma y such that x comma y, we can write like x comma y c comma d is equals to a comma b. So what is a comma b? It's complex number. Okay, so, and c comma d divides this. So if we will solve it, we will get some values. So I will not give you a proof, I will just write the values what we will get, which is x is equals to ac plus bd over, we will get these values, and y is equals to bc minus ad over c square plus d square, where c square plus d square does not equals to 0, which implies that c and d are not both 0. Okay, so we can write like c square plus d square does not equals to 0. So we can write it like z1 over z2 is equals to z1 into 1 by z2 is equals to z1 z2 inverse. Okay, so it is the division. Now we will study about the symbol iota and its powers. Okay, so basically it is customary to denote the complex number by 0, 1. Okay, by the symbol which is equals to iota. Okay, so with this notation we can find iota square, which is what? So what is iota square? It is so we have iota square is 0, 1 into 0, 1. What we will get by product formula multiplication we studied before about multiplication of two complex number. What is this? 0 into 0 minus 1 into 1 comma 0 comma 1 plus 1. Sorry. So what we will get is basically minus 1 comma 0. So this is the value of iota square. Okay, but we have agreed to write the complex number a comma 0 as simply a. Okay, so therefore we have iota square is equals to minus 1. So this is minus 1, which is iota square's value. So we similarly we can find iota cube, which is what? Minus iota, and iota 4, which is what? 1, and iota 5, which is what? Iota, and iota 6 is equals to minus 1, and so on. We can find any other values. Okay, we can find